this video, we will be studying about the effect of temperature on resistivity. Effect of temperature on resistivity or resistance, you can say. Okay, we'll be taking different materials. First one is metal, then electrolyte, then semiconductor. Okay, and we'll see the effect of temperature. The first one is metal. See, you know that R is equals to ml by n e square a tau. Okay. For a given material, for a given metal, n is your constant, e is your constant. Okay. Now, when temperature increases, let's say we are increasing the temperature. Okay, this will tend to what? Lambda RMS. This will decrease. This will create that tau. This is going to decrease. Okay, mean free path will decrease. Okay, obviously relaxation time will also decrease, and if this decrease, okay, then R will what? Increase, and if R increases, then rho will also increase. Okay, keeping the dimensions constant. Here L and A, they are assumed to be constant. Okay, so on increasing temperature, resistivity or resistance, they both will increase for warm, for metals. Okay, now for electrolyte, you can see for electrolyte, as T increases, what will happen? This will tend to decrease the viscosity. Viscosity will increase, so ions gets more freedom inside the electrolyte. Okay, hence resistivity or resistance of electrolyte will decrease. ठीक है, रेजिस्टिविटी या फिर रेजिस्टेंस आपका डिक्रीज करेगा. क्यों? क्योंकि आयंस को क्या हो जाएगा? मोर फ्रीडम टू मूव इनसाइड द इलेक्ट्रोलाइट. ओके, थर्ड वन इज third material is semiconductor. What will happen here? Okay, this is a very special case. Okay, on increasing temperature, charge carrier per unit volume will increase. Charge carrier per unit volume, this will increase since it is a semiconductor, right? And due to breaking of, and this increase what? This charge carrier per unit volume will increase, and due to breaking of covalent bonds, what will happen? See, on increasing temperature, there will be a breaking of covalent bond. Okay, on breaking, the tau is going to decrease. See, on increasing temperature, there will happen two things. The first thing is that your n will increase. Okay, and the second thing is tau will decrease, and this happens due to breaking of covalent bond. Okay, now you can see that if increase in n is more than decrease in tau, there will be some effect on R. But if increase in n is less than decrease in tau, then there will be another effect on R, because you can see that this n and tau both are in denominator. Okay, now if increase, see, generally it is seen that increase in n is much larger than decrease in tau, so the net effect is that the resistance is decreasing. Okay, okay, you have known the reason now. On increasing temperature, charge carrier per unit volume will increase, but at the same time there will be a breaking of covalent bonds, and due to this your tau will decrease. But increase in n generally is much larger than decrease in tau, so the net effect is that resistivity will decrease. Okay, this was your theoretical effects on resistivity or resistance due to temperature increase. Now temperature dependence of resistivity of material. Okay, how rho will depend on temperature. Okay, mathematical equation you can say. Okay, see, the resistivity of a metallic conductor generally is given by rho t is equals to rho 0 1 plus alpha into t minus e 0. Okay, or you can write RT is equals to RO. You've studied about this, I think, in 11th. Okay, alpha into t minus e 0. Okay, where alpha is a constant which is known as thermal coefficient of resistance of a metal of a material. Okay, if TO is equal to 0 degree Celsius, let's say from here TO is what, 0 degree Celsius, then RT will be RO 1 plus alpha into T. Okay, from here you can derive what, alpha is equals to RT minus RO upon RO into T. Alpha is temperature coefficient of resistance of material. Okay, now definition of alpha is, if you take RO as 1 and T as 1 degree Celsius, then alpha will be, see from here you can write alpha as RT minus RO upon RO into T. Okay, अगर RO 1 हो जाए, 1 हो, टेम्परेचर 1 डिग्री सेल्सियस, सो अल्फा क्या हो जाएगा, अल्फा विल बी RT minus RO. Okay, if the resistance of a wire at 0 degree Celsius is 1 ohm, then on increasing its temperature to 1 degree Celsius, the increase in resistance will be equal to temperature coefficient of resistance. Okay, means for the definition of alpha, you need to see this. Okay, if the resistance of the wire at 0 degree Celsius is 1 ohm, this is okay, right, and then on increasing its temperature to 1 degree Celsius, okay, this one, okay, on increasing temperature to 1 degree Celsius, then the increase in re- resistance will be equal to temperature coefficient of alpha. RT minus RO, this is what, increase in resistance, this will be equal to alpha. Generally you can write in note as well that for metal alpha is greater than 0, for semiconductors alpha is less than 0, semiconductors. Okay, and for alloys alpha is nearly constant. Okay, so these were some results. Okay, graphical representation you can also draw. Graphical representation of rho versus, actually this is very important. Okay, direct question has been asked in JMS on the basis of these graphs. Okay, for metals, suppose rho is on y-axis, T temperature is on x-axis. Okay, see here T is temperature, not time. Okay, it will be somewhat like this. Okay, for semiconductor, this is for metal. For semiconductor, this rho, this is T. Your graph will be somewhat like this. Okay, for alloys, I'm taking a general example of nichrome. Okay, nichrome is nickel plus chromium. Okay, your graph will be like this. Okay, resistivity of alloy increases with rise in temperature, but this increase is much smaller compared to the pure metal. Okay, this is what pure metal alloy. Its resistivity also increases, but this increase is much less than as we compare to the pure metal. Okay, fourth one is superconductor. Okay, for superconductor is also very important. This row C is increase not like this, where here that increases after a certain temperature. This temperature is known as TC, is critical temperature. Okay, below it the material shows superconductivity. Okay, below critical temperature. Okay, so this was variation of here, you can say rho versus T. Okay,